So, have you ever went into the kitchen and tried to turn on a stove? You know, like for example, if you're cooking adobo, sinigang, or whatever, but when you open the stove, it turns from an orange, a kind of orange reddish color, to a light blue hue. Like, what is that? Why is it blue, and why does it not remain orange the entire time? Right? And why are the hottest flames blue? If you're wondering the same things, then you and I are the same. Anyways, hi, my name is Cheska Rojas, and I am a homeschooler and professional teenager. Welcome back to another video of mine, and today we are going to be introducing a new segment called That's Not Rocket Science, where I explain or help you to understand a few scenarios in our daily life that may seem to have mind-boggling explanations behind them, when in fact, it's actually not rocket science. Today's questions. Why are the hottest flames blue? And in addition to that, how do UV lamps work? So to answer our first question, think of this setting. You're going to the kitchen, you're going to cook adobo, you turn it on, bam! It's an orange hue and it turned blue. What is that? There's a very simple explanation for this. So you remember Roy G. Biv? The colors of the rainbow? Roy G. Biv. You see that? Roy G. Biv? Yes. Roy G. Biv stands for red, orange, yellow, green, blue, indigo, violet. For high schoolers like me, I'm pretty sure we all learned this in grade 1. But for the younger kids watching this, now you know what Roy G. Biv means. Explanation to this is, as we ascend into Roy G. Biv, going this way, its wavelength decreases. Bam, wavelength decreases. But as we go this way, the other way around, its energy and frequency increases. So that's why red is the most easiest color that you can see with your eyes, because it has a long wavelength, around 700 nanometers, I think. And violet, the smallest wavelength color in the gang, has only a wavelength of about 350 nanometers, if I'm correct. I don't memorize it, but I'll put it right here, the information right here. So that probably explains why we see a lot of red. But what about heat? Like, why is it not red and why is it blue? Well, once again, as we descend on in our little rainbow, what do you call this? Rainbow thing, chart, or whatever, frequency and energy increase. So that's why blue has more energy to hold rather than red. It also explains why the hottest stars in our galaxy, including Rigel, is the hottest and the brightest, and our sun, not really a bright star, is orange. Now, our last question of the day, how do UV lamps work? So I'm sure you've all heard of a UV lamp once in a while. I don't know, maybe your mom has a UV lamp, maybe my mom has a UV lamp, maybe your tita has a UV lamp. And it's been known for disinfecting a lot of things. Like when I say a lot, I mean a lot. You find it on Shopee, on Lazada, on Instagram. But how exactly does it work? It's just light, right? Well, as I explained earlier about wavelengths and frequencies and energies and whatnot, UV lamps use ultraviolet radiation. And what is ultraviolet? Ultraviolet is a color that is far beyond the visible spectrum. It's a color of violet that we can't see, basically. And ultraviolet radiation works by plunging into the membranes of microorganisms, thus killing it effectively. And that's why it's used in a lot of disinfecting stations, like in restaurants when they disinfect their utensils, in hospitals. I can't name any other stores, but that's it. Also, UV lamps are categorized into 3. There's UVA, which is near UV, it's nearer to the visible spectrum table. There's UVB, which is the second one. It's used for tanning salons. It's quite mild and it can give you skin disease if you're not a morena queen like me, if you're not a melanin queen like me, you're probably gonna get skin disease if it's not handled well in a tanning salon. And UVC, the strongest UV radiation there is. These are the ones used in hospitals, restaurants. Like I said earlier, I don't know what else to name. And speaking of UVCs, our sun also radiates UV light, but thanks to our ozone layer, it doesn't really affect us as much as it should. But thanks to pollution and greenhouse gases, our ozone layer is slowly dying. But we're not going to talk about that in this episode of Rocket Science. Anyway, I think that's all for today. Now you know why blue are the hottest flames. Period. Blue are the hottest flames, and now you know how UV lights work. Oh, in addition, did you know that our sky is supposed to be violet instead of blue? But that's because our eyes can't see the color violet because it's far beyond the spectrum, and our sun is basically not hot enough to produce ultraviolet light. Well, that's all for this episode. Let me know if you cook adobo and you finally understand blue light. You feel me? And if you have more questions about light, or if you have a topic you want to talk about, make sure to comment down below. Once again, this has been your professional teenager, Cheska Rojas, and I'll see you soon. Bye!